Hi students, previously we have looked at how to separate solid mixture, solid liquid mixture, and now we'll be looking at liquid mixture. So what are some methods to separate them? So we will be learning about fractional distillation. So what's the purpose? Is to separate mixable liquids with different boiling point. So the word mixable means mixed together. One example will be ethanol and water. So you might have noticed that, what's the difference between simple distillation and fractional distillation? So for fractional distillation, it can separate liquids with different boiling point. And for simple distillation, we are just looking at obtaining the liquid from a solid liquid mixture. So this is an example of a fractional distillation setup. So we have a thermometer at the top. It's to measure the boiling point of the vapor. Same direction of the inlet and outlet of the water. Water going in from the bottom and going out from the top in the condenser. And this thing is called a fractional thin column. And we have a distillation flask, and lastly we have a Bunsen burner. So how does it work? It works the same as the simple distillation. Why? Because for simple distillation, actually the main concept behind simple distillation is that the substance with the lower boiling point will be evaporated first and distilled over and collected as distillate. So the liquid with the lower boiling point will distill over first. And what does the fractionating column do in this process? It provides a large surface area for vapor to condense on. For example, if there are some vapors that are not ready to be condensed and distilled on the other side, this fractionating column provided some cool surface area to condense this vapor and let it flow down back to the distillation flask. And the vapor of the liquid with higher boiling point will then condense along the fractionating column and fall back into the distillation flask. So during distillation of a particular liquid, temperature reading of the thermometer will remain constant at the boiling point. Constant means remain the same. So you notice that at 78 degrees Celsius, which is the boiling point of ethanol, it will remain constant for some time until all the ethanol has been distilled and heat up all the way to 100 degrees Celsius, and eventually the water will be distilled out. So how come this temperature reading will remain constant at the boiling point of ethanol and water? So to find out why, we need to study the next chapter, kinetic particle theory. It will explain to us how come the temperature reading of this vapor remains at this temperature before it has been distilled away. So it can be as simple as asking you which liquid will be collected first when you know the boiling point of these two liquids. So in this case, ethanol will distill first because it has a lower boiling point. And a lower boiling point means that you don't need to supply so much heat for it to vaporize. So like a thermometer, so you have to heat to a lower temperature first before you go up to higher and higher temperature. Alright. So how we know when to change the conical receiver flask to collect the second liquid? So when the temperature reading of the thermometer first start to increase beyond 78 degrees Celsius, this tells us that it's going to collect the next liquid already. So let's try it out. So name this method of purification. So you see a condenser. So what comes to your mind will be, is it simple distillation or is it fractional distillation? So in this case, you need to look out for, there any fractionating column in this diagram? Don't have, right? So this one is simple distillation. So what's the purpose of the condenser? So the purpose of the condenser is to cool down the vapor and condense into a liquid. So the word cool and condense must be there. Next, where will the cold water enter the water jackets of the condenser? It will go in from the bottom and exit from the top. And lastly, One item necessary to ensure smooth boiling is missing in this setup. Draw and label it in the figure above. So what is it? So if you need to recall, you can go back to the previous video and take a look at it, and you'll notice that the boiling chips is missing in this diagram to ensure smooth boiling. So the above setup can be modified to separate a liquid-liquid mixture containing ethanol and water. So state the additional apparatus needed. So we will need the fractionating column. So now we need to describe and explain briefly how ethanol and water can be separated using the apparatus mentioned in part 1. So the focus here is to decide which liquid will come out first and why. So let's briefly describe and explain the process. So as the liquid mixture is heated, ethanol vapor and water vapor will rise up to the column. Ethanol, which has a lower boiling point, will reach just the upper part of the fractionating column and is distilled first at 78 degrees Celsius. And the ethanol vapor will condense in the condenser and flow into the receiving flask. When all the ethanol is distilled, the temperature rises to 100 degrees Celsius and the water is distilled and collected. So you go one temperature at a time. The lower temperature first before the higher temperature. Just like when you heat a water, it will reach the lower temperature first, 25 degrees, 30 degrees, then so on and so forth until 100 degrees for the water to be boiled. So same concept as well. It will always boil. So it will always start at the lower temperature before going up to a higher temperature. So for a simple distillation or fractional distillation, it will collect the liquid with the lower boiling point first. So the next part of the video, we'll be talking about vapor chromatography. It's also another method to separate a liquid-liquid mixture, so stay tuned.